All right, this lesson is over conditional statements. This is a pretty quick lesson. It's also the first lesson to what I call Unit 1, Part B. So we're still kind of in the introduction to geometry. Now, Unit 1, Part B, a lot of this is going to be logic and reasoning, and I will just go ahead and tell you guys what we are going to be doing for the next few days is not really going to feel like math. Okay, we're just going to work on logic and talk about some different types of statements. So first off, a conditional statement is basically an if-then statement. And it relates a hypothesis to a conclusion. So let's talk about those two words. The if part, so what comes after the if, is the hypothesis. I also like to refer to that as the condition to be met. So that's the hypothesis. So like if this happens, then the conclusion happens. So whatever comes after the then is obviously the conclusion. All right, so what we are going to do today is going to be pretty simple. Again, a lot of this isn't going to feel like math. We're just going to take some random statements and we're going to turn them into conditional statements by putting them in if-then form. So you have to think about what's the hypothesis and what's the conclusion. The first statement we have is John will be grounded if he doesn't clean his room. So if we think about that statement, what is the condition to be met? And then what's the conclusion if that does or doesn't happen? Okay, so we start with if. And if we think about the hypothesis or what condition has to be met, it's if John doesn't clean his room. If John doesn't clean his room is the hypothesis. Then the conclusion, if that doesn't happen, would be he will be grounded. Will be grounded. That's how you format a conditional statement. And notice we did not change the meaning of that statement. Both sentences we have here mean the exact same thing. If you change what the sentence means, then you're not really writing a true conditional, okay? We want to keep it the same. Number 2, all kangaroos are mammals. So again, we don't want to change the meaning of the sentence. We just want to put it in if-then form. So it is okay to kind of add a few words to make your sentence make sense. But I want you to think about something. Are we saying all kangaroos are mammals? Or are we saying all mammals are kangaroos? Obviously, the sentence starts with all kangaroos are. So the condition to be met is that animal has to be a kangaroo. So if an animal is a kangaroo, then it is a mammal. These two sentences mean the exact same thing. If an animal is a kangaroo, then it is a mammal. All right? I did have to make a little correction on number 3. For some reason it said you can get your driver's license when you're 15 years old. We all know that's 16, so we can change it if you want it to be correct. Maybe try this one. I want you to pause. Just take this sentence, don't change the meaning, but put it in if-then form. Once you have that done, it should look like this. If you are 16 years old, then you can get your driver's license. Whoops. Whoa. Okay. So now we're going to talk about true or false. So conditionals are only true if you cannot come up with a counterexample. A counterexample is kind of something that would prove it wrong, okay? So number 4, here is one that is related to geometry, okay? So we have to think about some of our vocab words that we've talked about in Unit 1, Part A. And it says, if two angles are complementary, then they are both acute. So first of all, let's think about the hypothesis, the condition that has to be met. Two angles are complementary. This is the hypothesis. I'm going to label that. Label that with me. Okay, so if I have two angles that are complementary, meaning they add to 90 degrees, do they both have to be acute, true or false? This is actually true. You could not come up with a counterexample for this one. If two angles add up to 90, then obviously they both have to be acute because acute angles are less than 90 degrees. So it can't exceed 90, they would both have to be acute. Okay, so if the hypothesis is true and the conclusion is true, then this is a true conditional. We cannot come up with a counterexample. Number 5. If an animal is a bird, this is the hypothesis, then it can fly. So think to yourself, can you come up with an example that does fit the hypothesis, but the conclusion is not necessarily true? I can. I'm going to say this is false because I have an example that proves this wrong. My counterexample is going to be a penguin. Anything that is a bird that doesn't fly would be a counterexample. I'm going to put penguin. Penguin. I guess you could also put, what's another one? An ostrich. I don't think an ostrich flies. Chickens, I don't know. Do chickens fly? Chickens could be a counterexample. I know some people say they fly a little bit. Anyways, number 6. If an angle measure is bigger than 90 degrees, then it is obtuse. This is also one that I want you to think about. Maybe pause for a second if you need more time to think about it. Can you come up with a counterexample? Well, the hypothesis is an angle bigger than 90 degrees. It could be anything greater than 90 degrees. What about 180 degrees? Is that obtuse? Think about what we've learned about 180 degrees on a protractor. That looks like this. Did we classify this as an obtuse angle? No, we did not. We actually classified that as a straight angle. It's kind of like a line. So this one's also false. Counterexample. You could say 180 degrees or a straight angle. All right. So in short, a conditional statement, if it's not true all of the time, then it's false. If you can come up with just one example that doesn't work, the whole statement kind of falls through. Okay, so do your assignment over this. Reach out if you have any questions.